Not as direct as changing rectangular coordinates into polar coordinates as going backwards with these things. Just because what quadrant you're in really changes signs, but we don't see it in the numbers that we're given. For instance, here we have a radius of 7 and an angle of opening of 100 degrees, angle of rotation away from the positive x-axis. So we can find the location of this angle. That's not hard. It is in the second quadrant, and we get this measure of an angle coming out to it as 100 degrees. So from here to here is 100 degrees. We could set up a reference triangle. That wouldn't be hard. We would know that this side here, the radius, is positive 7. We would also know that the reference angle is 80 degrees. And we could label the sides x and y and go that direction. The problem with this is once we set up a sine or a cosine, like for instance if I want to solve for x, it would be cosine of 80 equals x over 7, and then x equals 7 times cosine of 80. But that's a positive number, and x here has to be a negative number. So what would be better is if we just use the 100 degrees, because cosine in the second quadrant is a negative number, and it would work out perfectly fine. So here I'm going to set up cosine of 100 degrees is equal to x over 7. And that'll give us the correct sign for the answer for x. Otherwise we'd have to always go by the picture instead of just using a nice little formula. The formula actually is x equals r cosine of theta. And then you don't have to worry about anything else. So 7 times cosine of 100 is negative 1.2. So x is approximately negative 1.2. And that kind of corresponds to our picture. This is going to be a short side compared to the y-axis. And the y formula is actually y equals the radius times sine of theta, in this case sine of 100 degrees. So 7 sine of 100 is 6.9. So y is approximately 6.9. So in rectangular coordinates, 7 comma of 100 from polar transforms into rectangular coordinates of negative 1.2 comma 6.9. Alright, for this one that's in radians, we're going to draw the picture where it is, but notice both of them are negative, and that's where it gets a little confusing with this conversion. So if I draw my picture, negative 2 pi over 7 is down here in the fourth quadrant. You're going down 2 out of 7 pieces. So it's going to be someplace in the fourth quadrant. That's not really the problem. If the radius was positive 4, the location of our point would be right here. But the problem is that it's negative 4, so it's going in an opposite direction to that orange line. So we're going to actually be in the second quadrant. And there's two ways of going about this. We know our point is located someplace in the second quadrant. We can either just go straight formula, x equals r cosine theta, y equals r sine theta, and we're going to get our answer. Or we can play around with it and change everything into positive values. This would be 5 pi over 7, and this would have a radius of 4. And we can do it that way. But I just think it's easier to say x is equal to r cosine of theta, and y is going to equal r sine of theta. And that way we don't even have to draw a picture. So we're going to get negative 4 cosine of negative 2 pi over 7, which is approximately negative 2.5. And that corresponds to where we are. We're someplace in the second quadrant, so x's are definitely going to be negative. If we plug in the y1, negative 4 sine of negative 2 pi over 7, we get approximately 3.1. And again, that kind of corresponds to the y-coordinate over here. So I'm pretty confident that that's right. But you could also try arc 4 cosine 5 pi over 7, and you'll find that it comes up to the same answer, because cosine in the second quadrant will be negative, and it's a reference angle of 2 pi over 7 over here. Vertical angles are congruent. And that's it.